Hello everyone, in today's video I assemble and test drive the FFR SC1 based 124 scale 85 Mustang. In the previous video I made, I showcased the process of modifying a 1/25th scale AMT 1983 Chevrolet Camaro body and interior so that it would fit the FFR SC1 chassis, which is a small-scale solid-axle rear-wheel drive platform that I've been spending a lot of time prototyping and testing recently in preparation for its upcoming release. Today I'm focusing on the Mustang that I'm building alongside the Camaro. Although both these projects use the same chassis, drivetrain, and suspension components, there are a few differences between these two builds. The biggest difference being that, unlike the Camaro, the Mustang will not have any interior. Although this will detract from the scale realism of the vehicle, this will provide a lot more room for the electronics and make the build process a little more simple. I started by assembling the chassis, which is comprised of 3 separate pieces, to make printing on an FDM printer easier. I make sure to install the panhard bar ends to the chassis mount before securing the rear chassis piece, since it's much easier to access. I applied some super glue to help ensure the chassis is solid. With the chassis assembled, I moved on to mounting the rear axle, starting by press-fitting the lower trailing arms, making sure to lube the surfaces first. I then secure the opposite end to the chassis using screws. Another more minor difference between this car and the Camaro is that I will be using a 3-link with panhard suspension rather than a torque arm with panhard. So the next step was to install the upper control arm. Once secure, I made sure that the suspension could move as intended and that there was no binding. I'm using a limiting strap on this car to prevent the axle from dropping too low, though personally I've been coming to the conclusion that it's probably more trouble than it's worth, but regardless, I noticed I needed to make it just a bit shorter, so I poked a new hole and cut off the excess, then mounted it back onto the axle and chassis. With the limiting strap in place, I moved on to installing the panhard bar. I happen to have a piece of 1.5mm steel rod that was the perfect length, so I glued each end of the panhard bar to it and mounted it to the axle. Finally, I needed to cut the springs to the correct length. I'm using 0.2mm diameter steel springs for a softer suspension with more travel than what I've built previously. The suspension feels great, though as I'll discover later on, these softer springs don't quite provide as much support as what I would like once the weight of the electronics has been added, so I will continue to be experimenting with different springs and spring combinations. In general, it's always a good idea to start off with more spring than what you think you need, since you can always remove some if you find that there's too much. With the rear suspension complete, I moved on to assembling the motor mount and gear assembly. There isn't much to this component. The lower gear goes between the two mounting pieces, which get screwed together, and the upper gear gets press fit onto the motor shaft. I like to use a little bit of glue to help ensure that the upper gear is solidly attached to the shaft. I then secure the motor to the motor mount using two M2 screws. When installing the driveshaft socket onto a resin shaft, it's important to make sure that the holes are aligned before installing the screw. I make sure the alignment is correct by pushing a pin through the hole prior to installing the screw. With the assembly complete, it can now be mounted to the chassis, though before doing so, I first want to assemble the driveshaft. I start by measuring the distance between the two driveshaft sockets, so I can get a rough idea of how long the driveshaft needs to be. With that measurement, I cut a 2mm rod to that length. I then install the driveshaft ends and test fit it. I continue to remove material until it is the correct length. Getting the length correct is important, since if it is too short, it can fall out, but if it is too long, it can bind between the axle and motor mount, so ideally, there needs to be just a tiny bit of wiggle room. Once I confirm that the length is correct, I glue each end to the shaft and then secure the motor mount to the chassis using 4 screws. I've showcased the assembly process of the front suspension and steering assembly previously. Because of its modular design, it simply mounts to the chassis with 4 screws. This particular assembly is an older prototype, so the tolerances, steering angle, and steering Ackerman are not ideal. These issues have been addressed in newer versions, however because I didn't have any on hand, I decided to just use this one for the time being. And again, because of the modular design, it won't take more than a minute or two to swap out this assembly. With this component installed, the suspension and drivetrain of the car is now complete. Next thing I did was install the wheels and tires, which are 18 by 10mm Type 181 wheels with Shore 40 VST silicone tires. If I'm remembering correctly, these wheels had a -1mm offset and 4mm of backspacing. I do plan on changing these wheels out for something different in the future. I used some water-soluble glue to help secure the tires, and I also applied a little bit of the same glue to the shaft before tightening the nuts to keep them from loosening. I now wanted to start focusing on the electronics, first beginning to brainstorm where I was going to mount each component. I needed to change the battery connector I'm using on the ESC so that it would be compatible with the battery that I'm using. I also needed to solder a JST plug onto the motor. After that, I did a quick test to make sure everything was functioning correctly. Before continuing to mount all of the electronics, I wanted to figure out how I was going to mount the body. The first thing I needed to do was attach the front bumper to the rest of the body. Unfortunately, there were no tabs or any easy way to line up or secure the bumper, since I believe it is designed to be secured to the model kit's chassis rather than being glued directly to the body, so I needed to come up with some way of mounting it. I did so in the same way that I did for the 1/24 scale Skyline body, first by cutting pieces of styrene that I will glue to the back side of the body and bumper to secure each side. This was a little tricky since the sides of the bumper stick out slightly further than the fenders, but with a little bit of bending, I was able to get a good fit. I used super glue because of its fast drying time, which made the process a little easier. I did my best to ensure that none of the glue would show up on the outside of the body. In addition to the super glue, I also used some shoe goo, which is much thicker, to help secure the styrene piece, since it didn't fit very snug against the body. With that completed, the bumper was now solidly attached to the rest of the body. A little bit of super glue did sneak past through the gap, resulting in a bit of a blemish, but fortunately nothing too unsightly. I went ahead and test fit the body onto the chassis to see how it fits. Everything seems to line up just about perfect. Both the wheelbase and the width seems to be pretty much spot on. To mount the body, I designed a couple of adjustable mounts that will secure each side of the body to the chassis using a total of 4 screws through the bottom. I started by assembling each mount. The mounts will sit on each side of the chassis as shown. The trickiest part was going to be securing them to the body. I started by figuring out how far out they needed to be positioned. I decided to try marking the position of each mount with the body installed, first by removing the door windows and using a marker to mark the position of each mount. I then used a ruler to make sure that the position was the same on each side. After that, I glued each mount. This method made it quite difficult to get the body precisely positioned. Eventually, I just positioned the body onto the chassis with the mount secured to the chassis, and I glued the mounts to the body through the window. Although this was more difficult to do, it resulted in the body being positioned very accurately. Once the glue had dried, the body ended up being very securely attached, even though it's only mounted in 2 locations. One thing I noticed is that the front wheels rub against the wheel arch. I'm able to adjust the position of the body slightly to help with this, but moving the wheel in slightly and possibly doing some sanding in this area is still going to be necessary to give enough clearance when turning. With the body mounts figured out, I was able to continue with installing the electronics. I started by mounting the steering servo. First, I needed to mount the steering arm to the servo, and then secure the servo to the chassis. This servo arm has the ball and socket joint on the outside of the arm rather than the inside, which is where it is supposed to be for this vehicle. However, it will still work with where it is right now. I grinded down a 1.5mm steel rod that I'm using for the steering link so that it is the correct length. Once it is correct, I glue each end to the rod. After doing a quick test to make sure that the steering servo is working, I began figuring out where I was going to position the receiver, battery, and ESC. I decided to place the battery in the rear. I then made a small shelf that I mounted towards the rear of the vehicle that the ESC and receiver will be secured to. Once everything was mounted, I cleaned up the wiring a bit with some zip ties. As I mentioned earlier, the added weight of all the electronics had a larger effect on the suspension than what I anticipated, so I will be making some further adjustments in the future, although I do like the look of this lowered stance. This car is utilizing a limited slip differential prototype. This current setup worked well for a lighter vehicle, but for this heavier car, there was way too much slip. This differential is adjustable, though it's tedious and tricky due to the small size. Since I was eager to drive the car, I decided to just assemble a new axle with no differential installed. I'll end up putting this axle back in the car after I've adjusted the diff, but for now I'm just going to use a simpler solid axle shaft. I am currently in the process of creating a separate video tutorial for assembling a MA10 axle. This will be a nice addition to the written instructions and images currently available. The process is quite simple. I start by sanding and trimming away any imperfections from each housing piece, making sure that each half fits together without any gaps. I also went ahead and ran a 0.8mm drill bit through all the holes just to make sure that they were clear. I then rinsed each piece with water to remove the dust. I also removed a few imperfections from the backside of the ring gear and then threaded it onto the axle shaft. I installed the two bearings for the pinion gear and then pushed the pinion gear shaft through the center of each bearing. I installed the driveshaft socket just like I did with the motor mounts, first by verifying the alignment with a pin and then threading the screw to secure the socket. After verifying that everything on the axle shaft is in the correct location, I start by marking the position of the ring gear with a piece of tape, and then rotate the ring gear back several millimeters and apply some high-strength metal glue, and then rotate the ring gear back into its previous position. After verifying that the position of everything is still correct, I repeat the same process for each wheel mount. I highly recommend gluing each part separately, verifying fitment in between, and not gluing everything at the same time. This way, if any adjustments need to be made, you can do so easily. I also highly recommend using a glue with a slow set time, which will allow for fine adjustments to be made after gluing. There isn't a lot of room for error during this step, so be sure to position and measure everything with precision. After allowing the glue to fully cure, I apply some grease and secure one half of the axle housing to the other. The axle assembly is now complete and ready to be installed. I then installed the lower trailing arms and upper control arm just like I did previously. Finally, I swapped the currently installed axle with this new one. With the new axle installed and everything functioning properly, I was ready to do some driving. The first thing I noticed was how fast this RF130CH 09520 motor was. For me, it seems a bit overkill, especially with no diff, and it doesn't quite seem to have the smooth low end like some of the other motors I've used. Personally, I'd want to give this car some more gear reduction, but I'm sure some people would prefer the faster, more Mini Z-like speeds. It certainly does make things interesting, especially if you were to have a lot more space. Here I can't even go past 1/3 throttle. But since everything seemed to be working well, I decided to set up a small track to drive around. Just like when driving any car around a track for the first time, I started out slow and gradually sped up as I began to get a feel for how the car handles and dialed in the settings on the transmitter. The biggest hindrance to the car's performance right now is the steering, though I anticipate the car will steer much better once I get the updated steering and suspension assembly installed. The car really is a lot of fun to drive, and it's nice to be able to set up a small track like this to race on, rather than needing a large, super smooth surface that is needed for racing larger scale vehicles. Fortunately, I had no collisions or problems while driving. Moving forward, I'd like to try and make the car's performance as scale as possible. I'll continue to experiment with different springs and tires, and mess around with the weight distribution as well. I made some adjustments through the transmitter to reduce the top speed of the motor so it wouldn't be overkill for this small track. If you are using this motor, or really any other motor with an MA10 axle that has a resin pinion gear shaft like this one, be careful since the pinion gear shaft can't handle a lot of torque. It's also important to keep the drive shaft angle as flat as possible. I look forward to continuing to experiment and improve the car both visually and performance-wise. As always, I'm going to conclude today's video by showcasing some of the awesome vehicles and projects that have been showcased over on the Make It RC Facebook group. I know the uploads have been a little sparse recently, though fortunately I have been able to do a lot of filming and I have made a lot of progress on various different projects. I just haven't had a whole lot of time to edit. There's also several projects that I'm wrapping up, and I want to get a little further along before I finish the video. I'm hoping that with the content that I've compiled, I'll be able to get back onto a little more of a regular upload schedule. But that is all for today's video. Thank you all very much for watching, and I will see you next time.